Mr. Harris here, and welcome to a new video. In this video, we're going to talk about the model of an atom. Now, first off, we'll look at the structure of an atom. Now, this structure was made famous by Niels Bohr. That was the scientist that's figured this out actually 100 years back, roughly around 100 years back. So he figured out that in the structure of an atom, so after, let's say we take a gold bar, we cut it into two, we keep cutting it, keep splitting it until you reach the final part, which is the atom. And let's say if you can zoom in inside an atom, you'll find three subatomic particles. So first off, it's a proton, which is this positive charge that you'll find. It'll be at the center of the atom. And then you have this neutron, that gray substance there, gray particle to be more exact. And also you have electrons. Now electrons here, they are negatively charged. And all this, we call them subatomic particles. Now subatomic particles, you can say they are really, 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 really tiny. They're really, really small. Okay. Protons, as I said earlier, they're positively charged. And to help you memorize this, proton, it has a letter P, and positive, it also starts with a letter P, so that would help you. Neutrons, they are not having any charge, they are neutral, and because they're neutral, to help you remember that, you can see the word starts with new, newt or new, and this is also neutral, so it's neutral, meaning it has no charge. It's neither positive nor negative, so it's like zero. Electrons, on the other hand, they are negatively charged. So electrons are negatively charged, and that's the only remaining one, so hopefully that could help you remember that. Negatively charged electrons. Now the interesting thing is, at the center of the atom, that is where it's called the nucleus. Okay, this is at the center. And at the center of the nucleus, you'll notice that there are two subatomic particles. You'll notice that there is a proton. Yeah, maybe they didn't show it here, so I'll write it for you. You have the protons, which is the positively charged particle. And also you have the neutron, which is neutral charge. It has no charge. This is the neutron. And then, of course, there are electrons roaming around outside. Electrons. Now here, at the nucleus, at the center, the protons and neutrons, they are over there. How about electrons? Electrons, you see they are moving in this circle thing. Now this circle is what we call a shell. S-H-E-L. L. So electrons, they're not at the nucleus, rather they're far away from the nucleus and they're moving in circles, you could say. They're moving in circles. Just like how planets they orbit. So same thing over here, it's orbiting around the nucleus. And in between the nucleus and these shells that I'm talking about, it's just basically empty space. So this white space that you see, it's basically empty. There's nothing there. So just to summarize so far, as mentioned, protons, they have a positive charge. So you can see it has, so if we were to assign a number to it, let's say it's positive 1. Neutrons, because it's neutral, it has no charge. So if you assign a number to it, 0. And electrons, because it's negatively charged, I shouldn't write electrons here. It's negatively charged. So if we were to assign a number to it, we'll assign -1. And the mass, now the mass of a proton and neutron is 1. And compared to that, electrons, it's very, 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 very small compared to protons and neutrons. Okay. But this point over here, the relative mass, it's not as important as the charge. This one is the key point that you need to know. So in an atom, there'll be the number of protons would always be the same to the number of electrons. Now what does that mean? Now look here. How many protons are there in this particular atom? You'll find that there is 1 proton, 2 protons, and 3. There are 3 protons over here. So let me write it up here. there are 3 protons. And each proton, there is a positive 1 charge, right? You can see there's a positive 1 charge. So in total, if there are 3 protons, what's the total charge over here? Yep, so it'll be plus 3 charge. Okay, how many electrons are there? So let's count the number of electrons. There's 1 electron up here, there's another electron down here, and there's another electron here on the left. So there are also 3 electrons. Electrons, they are negatively charged, and if we were to assign a number, it's -1. So in total, as you said, there are 3 electrons. So the total charge for this would be -3. Okay, so if I were to ask you guys, what's the overall charge? So basically, I'm asking you, if I add them up, what's the overall charge? Now, if it's plus 3 charge from the protons, minus 3 charge from the electrons, you notice that they all cancel out one another. They cancel out one another. The overall charge for an atom here is 0. Okay, but just one extra bit over here. If I were to ask you, hey, how many neutrons are there? So you can also count a number of neutrons. There's 1 neutron, 2 neutrons, 3 down here, and in the middle there's one more, 4. There are 4 neutrons. Just an extra question. But neutrons, they carry no charge. So the charge, there's no charge. The charge is 0. So we don't really care about the charge for neutrons. So overall, as I said, the overall charge for an atom carries no charge. As seen over here, you found out it's 0. That's why it carries no charge. That's what it means by this statement. So we would say that an atom, it is electrically neutral, meaning it has overall there are no charge. So to summarize this part, atoms, they're made up of protons. Protons having positive charge. So that's the short form of writing positive. Neutrons, they have no charge. And electrons, they are having a negative charge. So let's go ahead and write it down. Negative, I'll write it like this, negative charge. Okay. Now, the nucleus of an atom contains the positively charged. What's the positive charge? Yep, it's the proton. And what is neutral? Of course, and the neutron. So at the nucleus, you'll find the proton and the neutron. And what's moving around the nucleus in those shells that I was talking about? Yep, those are the electrons. Okay. In an atom, the number of protons is the same as the number of what is the same. So let me go back and show you the example. Here, as we said, the protons, there were 3 protons here, and how many electrons? 3 as well. But did you notice the number of neutrons was different? So sometimes the number of neutrons may also be the same. It would depend. But always the number of protons and the number of electrons for an atom is always the same. Okay, so let's write it up here. The number of protons would always be the same with the number of electrons. Okay, so this was the introduction to Niels Bohr's structure of an atom. The number of protons would always equal to the number of atoms, and inside the nucleus you have the protons and neutrons, and around the nucleus that's moving around, that's called the electron. Okay, and then I'll see you in the next video.